So let's do one more example where we find the critical numbers and the absolute max and min values on the interval. So here's my function. It's g of x equal to x times the e to the x over 2. Okay, so that's up in the exponent. And I'm going to be maximizing and minimizing this on this interval, the closed interval, -3, 1. So let's do part A, and the first thing I'm going to do is I'm going to take the derivative of the function using the product rule. So this is x times the derivative of e to the x over 2. So that is just itself times the derivative of this guy, because we're going to be using the chain rule. So that's 1/2, and plus, okay, and then I'm going to take the derivative, or my exponential function times the derivative of this function, which is 1. So let's clean this up a little bit. I see that both terms have an e to the x over 2. So I'm going to factor that out, and I'm left with 1/2 x plus 1. Okay, and that is my derivative. So the first thing to note when we want to find the critical numbers, okay, is we are going to look at our original function and just make sure that we know what the domain is. So what is the domain of g of x? Well, if you look at this function, you can see that, we never have division by 0. We don't have any even roots. We don't have any logs or anything that could give us trouble. So the domain of this function is all real numbers. Okay, you could also write that like this if you wanted to, or you could just say all real numbers. So the domain is all real numbers. And this function is also continuous on its domain. And so it's continuous on the real numbers also. So this is a really nice function. So in order to find the critical numbers, then what we're going to have to do is we're going to have to figure out, first of all, where is the derivative undefined? This derivative, for similar reasons to what we had over here, this derivative is always defined. Okay, and we also want to figure out, well, where is the derivative equal to 0? Okay, now the key thing to notice here is that this quantity, an exponential function, so with base e raised to any power, this is always going to be positive. So this is, so in other words, e to the x over 2 is, it doesn't matter what x is, this is always a positive number. That means that this expression is going to be equal to 0 whenever 1/2, if 1/2 x plus 1 is equal to 0. So that occurs when x is equal to -2, right? If I just solve that equation. So the derivative will be 0 if x is equal to -2. Okay, so that said, my critical numbers are therefore, or my critical number is therefore just x equal -2, and that's it. Okay, so that is the answer to part A. Now, in order to answer part B, where we want to find the absolute or the global max and min values of this function on the given interval, and that's this interval right here. Once again, we're going to be using the extreme value theorem and the closed interval method. So if you haven't seen the other videos, this is just a theorem that says that if my function is continuous on a closed interval, and we have this condition met with our function, it's continuous on -3, 1. Then it must attain the absolute maximum and minimum value. The method that we're going to use is the closed interval method. So step 1, we find all the critical numbers. Step 2, we just evaluate the function at the critical numbers and also at the endpoints of the interval. And then the largest value is our absolute maximum. The smallest value is our absolute minimum. So let's go ahead and do that. So we already have step 1 done, and that's that the critical numbers are, we found the critical number. Critical number is just x equal, I think we said -2. Step 2 is we start plugging things in. So I'm going to say f of -2 is equal to, g of -2 is equal to -2 times e to the -2/2. So that gives me -2e to the -1, or -2/e, which is approximately -0.736 if I plug that into my calculator. Now, that is the critical value. The next thing we want to do is plug in the endpoints. G of -3 is equal to -3 times e to the -3/2. So this is equal to -3 over, let's see, square root of e cubed. And if I plug that into my calculator, that is approximately -0.669. Finally, let's plug in g of 1. That's our other endpoint. And we get, let's see, 1 times e to the 1/2. So that's square root of e, which is approximately 1.649. So step 3 of the closed interval method basically tells me that the smallest value here, which is this value, is the absolute minimum value on the interval, the closed interval, and that the largest value of these will be my absolute maximum value of the function on this closed interval. So here is the graph of the function, and I'm also going to point out the interval of interest. So that is from -3 to x equal 1. And if we look at the function on this interval, we can see that the absolute maximum value is occurring here, and it is at the point 1 comma approximately 1.649, and that actually is where we found, using the closed interval method, that is what we found the absolute maximum to be. We can also see that the absolute minimum seems to occur over, the graph kind of dips down around here. So the absolute minimum occurs at -2, -0.736, and that is exactly what we got for our absolute minimum value, and we found that it occurred at -2.